नमस्कार दोस्तों. So let's revise very quickly thermodynamic. So you know mechanical work equal to F into D. F is the force, D is the displacement, and electrical work is E into Q. Gravitational work equal to gravitational force, that is mg into height. Now mechanical work equal to P into delta V. Here P is the pressure, delta V is change in volume. So mechanical work is P into delta V. Here P is the pressure and delta V is the change in volume. Now we know that for expansion, we have W equal to negative, since V2 is greater than V1. You know about system and surrounding, so from there it is. And for compression, it is W equal to positive, that is because V2 is less than V1. And unit of work 1 calorie, that is represented by 1 CAL, equal to 4.184 into 10 cap 7 erg, which is further equal to 4.184 joules. Now enthalpy is nothing but since we know that enthalpy is represented by H, and enthalpy is defined as the total heat content of the system at constant pressure. So how can we write this? H equal to E plus PV, and change in enthalpy delta H equal to delta E and plus delta PV. Okay, then delta H equal to delta E plus P2 V2 minus P1 V1. Delta H equal to delta E P delta V plus V delta P. Just differentiating. Then at constant pressure, this will go to 0, so we will be having this one, delta H equal to delta E plus P delta V, and this can also be written as delta H equal to delta E plus delta Ng RT for chemical reaction. Reactions. Now let's see first law. Mathematically it is Q equal to delta E minus W. Delta E equal to Q plus W. Since Q is the heat absorbed or evolved, it is positive if absorbed and it is negative if evolved. ठीक है. For isothermal process means isothermal delta T equal to 0. So delta E equal to 0, Q equal to minus W. So example, we see that heat absorbed is used in work done by system. If Q equal to minus W means heat absorbed is used in work done by the system. And for adiabatic system, the heat absorbed or evolved will be Q equal to 0. Then in that case, for adiabatic, since Q equal to 0, therefore delta E equal to W. So for internal energy is used up in work done by the system. If work is done on the system, its internal energy will increase, or if work is done by the system, its internal energy will decrease. In adiabatic process, the work behaves as state function. And for isochoric, okay, let's see. For isochoric, delta equal to Q minus P delta V. Delta V equal to 0, QV equal to delta E. Heat absorbed at constant volume increases, internal energy also increases. For isochoric process, means volume will go 0. Process heat behaves as a state function. For isobaric, P's pressure is constant, delta P equal to 0, so QP equal to delta H. Now work done for irreversible process, W equal to minus P external into delta V. For reversible process, W equal to minus V1 to V2 PdV. For reversible isothermal, this is the formula, W equal to minus 2.303 nRT log 10 V2 V1, then equal to minus 2.303 nRT log 10 P1 upon P2. In adiabatic process, minus W equal to delta E. For an ideal gas, W equal to NCV T2 minus T1. Then W equal to NR gamma minus 1 T2 minus T1. When an ideal gas freely expands in vacuum, then the obtained work done is 0 because P external will go to 0. Reversible expansion process are more efficient than the irreversible expansion process. Now this is entropy of a system, is a measure of the degree of randomness or disorderness of the system and is denoted by S. Delta S for reversible isothermal process. And just take the screenshot, these are the formulas and everything is written down.